Okay, so for this question, it's asking us to represent 2.375 in the floating point form. Key things we need to notice is it's asking for 8 bits for our mantissa and 4 bits for our exponent. You'll also notice it's mentioning the key term 2's complement. Our mantissa and exponent are represented in 2's complement anyway. This is something that we won't teach you because it becomes confusing, but essentially when you have a positive value like this, you do not need to flip your values, and it's just a trick. They're trying to throw you off. Okay, so when you see this in the future, please do not get confused by this. Okay, so looking at this, we have 2.375. If we start out, the first thing I want to do is represent this value in binary with the smallest amount of bits. Okay, so if I go for 1, 2, so it would be 1, 0, and then 0.5, 0.25, and don't forget, if you can't remember what comes next, use your calculator, use your answer, and divide it by 2. But I know the next value that I have is 0.125. Okay, so this is what we get. 5 bits. The next thing that we'll need to do is to normalize it. By normalizing, we simply need to do one thing. Put 0 at the front. Because we're going backwards and we already know our decimal place is, we're sort of reversing the step. So this step here of normalizing it might throw you off, but that's all you need to do to solve that issue. Okay, the next thing you'll need to do is notice, if we look back at our question, it says 8 bits. So at the moment we have 1, 2, 3, 4, 5, 6, and then our remaining values after we put our 1, 0 to the left to normalize is to put them here. So 7, 8, and there we have our mantissa. The next part we'll need to do is work out our exponent. This is where our floating point starts. And if we count 1 and 2, this is where our floating point has moved to. So our exponent is going to be 2, and we're going to represent that using 4 bits. So 1, 2, 4, 8. And then we said it's going to be 2, so 0, 1, 0, 0. That's that. Okay. What you can just do, just to make sure that you get your full marks, is to just specify mantissa equals. And then the next bit, you could just say your exponent as well. And there you go. And looking at the mark scheme, one thing you'll notice is where you're going to get your marks. So when we originally break down our binary value with the smallest amount of bits, we get a mark for that. Your next mark is going to be your mantissa and exponent. So we get a mark for this, and we'll get a mark for that. And then there we have all 3 of our marks.